Hi friends, welcome to session 9 on total differential equations. In this session we are going to study about the solution of simultaneous equations of the form dx by p is equals to dy by q is equals to dz by r. Okay, let us start. So let us first consider the simultaneous equations. p1 dx plus q1 dy plus r1 dz is equals to 0. First equation, and p2 dx plus q2 dy plus r2 dz is equals to 0 as second equation, which can be written in the form of p1, that is dividing each by dz. So we have here p1 dx by dz plus q1 dy by dz plus r1 is equals to 0, and p2 dx by dz plus q2 dy by dz plus r2 is equals to 0. Now, by the method of cross multiplication, so by the method of cross multiplication we have here, by the method of cross multiplication, it can be written as here, then we have dx by dz divided by, we know the method of cross multiplication, so you have to write, first you have to write the coefficients, then there this one dx by dz dy by dz and 1, it is like this here. I hope all of you know this method of cross multiplication, dx by dz, then dy by dz, then coefficient of r1 is 1. Then write the coefficients p1, q1 and here r1, then p1, q1, r1, then you have to repeat these two here. Then you have to repeat this p1 and q1, you have to repeat here. This is p1 and here this one is you have to write here p1 and q1 and q2 it is. This is all p1, p2, no, it is r2, it is p2, p1, p2 like this you have to write here, q1 and q2 you have to write like this. You know the method of cross multiplication, it is dx by dz, it is dx by dz divided by, you leave this column and row, then cross multiplication like this, q1 r2 minus q2 r1 like this it is. So this is what here, dx by dz, dx by dz is equals to, dx by dz is equals to, you have to leave this column, no, it is, then it is q1 r2 it is, this is q1 r2 minus q2 r1 like this, q1 r2 minus q2 r1 is equals to minus this dy by dz, we can take minus in numerator, in numerator or in denominator also we can take here, anywhere you can take. It is just again it is like this here, leave this column and row, then cross multiplication it is p1 r2 like this here. So it is otherwise we can take like this. So it is p1 r2 minus r1 p2 it is. Then it is equals to 1 divided by, leave this column and row, then it is cross multiplication p1 q2 minus p2 q1 it is, p1 q2 minus p2 q1 or q1 p2, both are same. So it is like this. This is the method of cross multiplication. So I hope all of you know this one, isn't it? Okay, if you don't want to take this minus sign, what you do is you just leave this cross, you just leave this column and row, then you have to go for like this, r1 p2 minus r2 p1, then it will become here plus. So it is nothing but here, this implies it is nothing but dx by dz divided by, this is q1, no, it is q1 r2 minus q2 r1 is equals to, take minus sign common in denominator, it becomes here plus, this one is dy by dz divided by it is r1 p2 minus r2 p1 is equals to 1 divided by p1 q2 minus q1 p2 it is. So or we can also do it as here, or it is nothing but here, if you divide this one, if you multiply all the terms with dz, it becomes here dx divided by q1 r2 minus q2 r1 is equals to dy divided by p2 r1, this is p2 r1 minus p1 r2 is equals to 1 divided by p1 q2 minus p2 q1. So this is nothing but here, or it is nothing but it can also be written as here dx divided by p is equals to dy divided by q is equals to dz divided by r, where this p is q1 r2 minus q2 r1 and this capital Q is p2 r1 minus p1 r2 and this r is nothing but p1 q2 minus p2 q1. So thus the simultaneous differential equations 1 and 2 can be written as, thus simultaneous equations 1 and 2 can be written as, can be put in the form of, can be put in the functions in the, can be put in the form of equation 3. This is our equation 3. Can be put in the form of, equation 3. So here we have this is the equations 1 and 2 can be written in the form of this equation 3 also, that is the simultaneous equations p1 dx plus q1 dy plus r1 dz is equals to 0 and p2 dx plus q2 dy plus r2 dz is equals to 0 can be written in the form of dx by p is equals to dy by q is equals to dz by r, where p, q, r like this. So then we can say that here, so this is also the form of a, this is also the form of a simultaneous equation. This is also one of the form of a simultaneous equation. So we can, to solve this equation we have two methods. So let us study these two methods. Okay, let us take a first method. First method is the method of making the groups, that is grouping. So first we have to choose here, first we have to choose any two members of equation 3. So that is here, first we have to choose any two members of equation 3. That is, you write, first choose any two members of equation 3. That is here, say dx by p is equals to dz by r. Then integrating we have here, integrating we obtained, it is a function of x and z. Phi of x comma z is equals to c1. Take this one as equation number 4. So again we take other two members of equation 3. Again take other two members of, so how do we make these groups, means we have to separate the variables, no? So which is easy to separate the variable, then you have to select those two terms. Okay, so again you have to select one more set, that is again you have to take two members of equation 3, say dy by q is equals to dz by r, and integrating we have here, it is a function of here, it is a function of y and z. Phi 2 of y z is equals to c2. Take this as equation number 5. And these two equations 4 and 5 gives the solution of the simultaneous equation 3. So equations 4 and 5 constitute the complete solution of equation 3. So this is the method of grouping. That is, what you have to do is here you have to select any two members of the group which is easy to separate the variables, then integrate that one. Again you have to take two more members of equation 3 and you have to equate and then integrate, you will get the function, that is solution as in terms of those two variables. So these two solutions gives the complete solution of equation 3. This is about the solution. This is about the first method, that is method of grouping the terms. Let us take some examples in this. Let us take one example in this. Solve dx by z square divided by this is dx divided by z square y equals to dy divided by z square x is equals to dz divided by xy square. Take solution here. So first if let the okay, let us take one example here. Solve dx by z square y is equals to dy by z square x is equals to dz divided by xy square. So take this one as equation number 1 and let us use the method of grouping. So I told you in the method of grouping, you have to select any two terms which is easy to integrate this one. So that is here easy to integrate means we have to use the method of this one is separating the variables. So see here, if you select these two terms first, then both the denominators are having same common term, that is z square get cancelled. So it is we have only two variables in this, dx by y and dy by x. Then easily we can solve this one. So for that purpose, you take here, consider first two terms here, that is taking the first and second members. That is here taking the first and second member. So what we have here? It becomes dx divided by z square y is equals to dy divided by z square x. This implies on both the denominators we have z square. No? This implies it is dx divided by y is equals to dy divided by x. That is cross multiply this one. So what we have? This implies it is x dx is equals to this is y dy. Otherwise we can take here this one as on both sides we can take this one as here integrating on both sides we have here x dx is equals to integration of y dy. This implies it is integration of x is x square by 2. It is equals to y square divided by 2. Then constant of integration we can take here this one as c1 we can take. So take all the terms on one side here it is. Otherwise take LCM and cross simplify. It becomes x square is equals to y square plus 2c1. Or it is x square minus y square is equals to c. Where this c is nothing but 2c1. Where c is nothing but here 2c1. This is the first solution. So next again you have to take here, if you take these two terms together then it will become easy. So x will get cancelled. So we have only two variables x, y and z. So next we consider second and third terms of equation 1. Then we have dy divided by z square x is equals to dz divided by xy square. Then this implies on both sides we can have x get cancelled. It becomes dy divided by z square is equals to dz divided by y square. Then cross multiply this. It becomes here y square dy is equals to z square dz. Now variables are separated, then we can integrate this one. Y square dy is equals to integration of z square dz. Then this implies integration of y square is y cube divided by 3 is equals to, so let us separate the variables first, then it becomes here integration of y square dy is equals to z square dz, and integrating we have here y cube divided by 3 is equals to z cube divided by 3 plus constant of integration here c2. Now let us take LCM and simplify. It becomes y cube is equals to z cube plus 3c2. Then this implies here y cube minus z cube is equals to c. This one is we can take here c2, no 3c2 we can take, c dash we can take here. Otherwise it is c2 dash I will take here 3c2 dash. So it becomes simply c2 it is. This is equation number 4 it is. Equation number this is 1, 2, 3 it is. So here where c2 is equals to 3c2 dash. So equations 2 and 3 form the complete solutions. So equations 2 and 3 form the complete solutions. The complete solution of equation 1. So this is all about this today's session. Thank you very much for watching this video. Thank you.